All right, so today we are taking on more parallel line and transversal proofs. And one thing that I've highlighted for emphasis is that all of these proofs, we are proving the converse of the originals. So when we're proving a converse, that means that we are literally flipping around the hypothesis and the conclusion. So in every single one of these proofs, we are given an angle relationship, and the goal is to build to why it is that the lines are parallel. So one thing that you're going to see me do in all of these proofs, imagine a visual like this. So here I have two lines cut by a transversal. I'm going to try to build up to showing that I have a pair of corresponding angles that are congruent. So for example, this angle right here, upper right hand region, and then this angle right here, upper right hand region. So if I can show that this angle right here is congruent to this angle right here, that is what's going to lock my lines into a parallel position. And my reason would be the converse of the corresponding angles postulate. So keep that in mind. That is where I'm trying to get to in the end. That is why my lines are going to be parallel. Okay. So just like in the other batch, we saw that these two on top were very similar. That is true here as well. So my starting point is that these angles here, 3 and 6, they are congruent. So we're starting off with a pair of alternate interior angles. They are congruent. So we need to build our proof and show why it is that our lines must be parallel. So first I'm looking at my original statement, 3 is congruent to 6. It was given to me. So I want to look for another relationship that I can connect to that does not rely on my lines being parallel. I do not know my lines are parallel. It's what I'm trying to prove. So if I look at what I can build off of, here's angle 3. Angle 3 is congruent to angle 2 because they're vertical angles, right? That had nothing to do with this line over here, right? Because again, I do not know that my lines are parallel. It's what I'm trying to prove. So I can connect angle 3 and angle 2, right? They're vertical angles. So I can use the vertical angles theorem. Okay, you could write that as a sentence as well. If we have vertical angles, the relationship is that they are congruent. That's fine. I'm going to write it as the vertical angles theorem. I think it's faster. We've proven it. We can now use it in this new batch of proofs. So now, right now, 3 is connected to 6. 3 is connected to 2. Block out the diagram entirely. Don't focus on it. Look at 3 to 6 and 3 to 2. So then I can swing back and connect 6 to 2. I'm really completing that three-way connection, right? My little chain rule. So if I have that three-way connection, my little chain, that's really the transitive property. So I can write right here the transitive property of congruence. But anywhere that I see the transitive property, I could also argue substitution. So I can plug in here, substitution property of congruence would work also. I'm always writing the two options. You only have to write one. So now look at where we are. 3 was congruent to 6. Let me write it like this. It's like saying that A is the same as B. Okay, 3 is congruent to 2. Those are vertical angles. It's like saying A is the same as C. Okay, and then if I swing back, right now I can say, well then 6 has to be congruent to 2, just like B would have to sync up with C. Right, so I'm just reminding you of what the transitive property is doing. It's building you a little chain of 3 or more parts. All right, so now I've established that 6 and 2 are congruent. Look at where 6 and 2 fall. Right here and right here. So this takes us back to this visual. We've just established that we do have a pair of corresponding angles. They are congruent, so that leads me to the lines being parallel. So my reason right here would be the converse of the corresponding angles postulate. Right? And what that says is, well, if I have a pair of corresponding angles that are congruent, then those lines being cut by the transversal, they have to be parallel. All right, this next one is pretty similar. So now the converse of the alternate exterior angles theorem. So our starting point here is that angle 1 and 8, these alternate exterior angles, they are congruent. And we want to build a proof that shows why the two lines have to be parallel. So again, I'm looking at my picture and I'm looking for any other angle relationship that does not rely on my lines being parallel. So if I look at angle 1 for a moment, I can see, well, angle 1 is congruent to 4, right? I didn't need that other line to help me make that connection. They're vertical angles. So I can say that angle 1 is congruent to angle 4. Vertical angles theorem. Okay, and I'm just going to block the diagram out of view and think about what I'm connecting. 1 is congruent to 8, 1 is congruent to 4, so now I can swing back and connect 4 and 8. All right, why? Right, well, it's just that three-way connection. I would say transitive property again, or I could argue substitution. They both work. So transitive property of congruence, or you argue substitution. I will accept either one. All right, so now what is it that we have achieved here? We've just gotten angle 4 congruent to angle 8. So back to this visual. Because these corresponding angles are congruent, that is what's locking these lines into a parallel position. So my reason would be the converse of the corresponding angles postulate. So in both of these proofs, I'm really doing the same thing. I'm trying to sync up a pair of corresponding angles, because if I have those corresponding angles in the same spot, right, that they're congruent, that locks my lines into a parallel position. It's just like when we have slopes that are the same, that creates parallel lines. All right, this next batch of 2 are also very, very similar. So in my first one, this one is the converse of the same side interior angles theorem. So our starting point is that 3 and 5 are supplementary, and we're trying to build towards why are the lines parallel. So again, I'm always keeping my eye on the prize. I'm trying to think of how can I ultimately connect a pair of corresponding angles and show that they're congruent, because if I can do that, then my lines have to be parallel. All right, so my starting point right here, 3 and 5 are supplementary, given. How do I build off of that? Well, what does it mean to be supplementary? It means that the measures add to 180. So the measure of 3 plus the measure of 5 equals 180, right? That's what it means to be supplementary. So I'm citing the definition of supplementary. If you wrote me a sentence that said supplementary angles add up to 90 degrees, not to 90, to 180 degrees, then I would take that. So if angles are supplementary, then their measures sum to 180, that would be fine too. I'm just going to write it as the definition of supplementary. So now, when I think of where I am and where I need to be, well, right now, I have an equation built that two measures add to 180. So typically, when I'm at this point, I kind of look at the picture and I look for another pair of angles that also sum to 180. And I can see this pair right here. So I can see that the measure of 1 plus the measure of 3 must equal 180 as well. They form a linear pair. Linear pairs are always supplementary. So I'm using the linear pair property. If you write linear pairs are supplementary, I will take that too. All right, so now look at where we are and where we need to be. So right now I have these two equations built where the sum of two measures equals 180. So if these equal 180 and these equal 180, these have to equal each other. That's the transitive property or substitution, either way. So let me just remind you, A equals B. So I'm saying that this is the A, this is the B. Just like here, let's say I call that C, C equals B, right? The B here is the 180. So if A equals B and C equals B, well, then A has to equal C. Right? It's making me that little three-way chain. That's the transitive property. So now I can write this next step as measure of 3 plus measure of 5 equals the measure of 1 plus the measure of 3. So I could argue transitive. These are equations now, so property of equality, or substitution. Property of equality. All right, so now look at where we are and where we need to be. I'm trying real hard to get to some corresponding angles and show that they're congruent. And where I'm at right now, I'm really close to getting there. Right? I can see that the only corresponding angles marked in my picture are 1 and 5. So if I can get to those two angles and show that they are congruent, that is what is locking my lines into a parallel position. So now that I'm here, I can subtract away this measure of 3. So that's going to get me the measure of 5 equal to the measure of 1. Subtraction, property of equality. Okay, their measures are equal, and if their measures are equal, the angles themselves must be congruent. Right? It's just a little conversion. So if the measures match, the angles must match also. So this is the angle congruence postulate. Okay, so now looking back at my picture, have I connected a pair of corresponding angles? Have I showed that they're congruent? I have. So now I can reach my conclusion that the lines have to be parallel because of the converse of the corresponding angles postulate. Okay, so the next one and the last one is very similar. This time, we are starting with a pair of same side exterior angles. We are told that 2 and 8 are supplementary, and we're trying to build up to why are these lines parallel. So I'm keeping my eye on the prize, right? I'm trying to focus on how do I connect a pair of corresponding angles and show that they are congruent. So I'm building off of, first, this statement. 2 and 8, those are supplementary angles. What does it mean to be supplementary? It means that the measures sum to 180. Definition of supplementary. All right, what are the only corresponding angles that are marked in my diagram? Well, 2 and 6. So I'm just keeping my eye on what I want to connect in the end. So can I build an equation that's very similar to this one right here? Yes. Right here, I see a linear pair. And with a linear pair, right, they're always supplementary. Their measures add to 180. So here I can say that the measure of 6 plus the measure of 8 equals 180. My reason would be the linear pair property. Linear pairs are always supplementary. Their measures add to 180. So now, back to here, it's very similar to what I did over here. If I call this A, and then this is B. If I call this C, this is also B. Right? These measures add to 180, so do these. So they must equal each other. So now I can say that the measure of 2 plus the measure of 8 equals the measure of 6 plus the measure of 8. Right? I'm making that three-way chain. 3 or more is the transitive property. So here I'm going to say transitive property of equality, right? We're looking at equations. And anytime I use transitive, I could also argue substitution. So, or substitution property of equality. Okay, so again, I'm trying to get 2 and 6 connected. So looking at where I am now and where I want to be, well, I can subtract away that measure of 8. Now the measure of 2 equals the measure of 6. And I got there using subtraction. So subtraction property of equality. Okay, I'm so close. Right now I know their measures are equal, and I want the angles themselves to be congruent. So I can convert it and say angle 2 is congruent to angle 6. So this is the angle congruence postulate. So now I've done my job, right? I've synced up a pair of corresponding angles, just like these. I've shown that they are congruent, and because they are congruent, my lines must be parallel. So my reason is the converse of the corresponding angles postulate. All right, so we've used a bunch of converses in these proofs. So I want to remind you, since we're proving the converse of alternate interior, alternate exterior, same side interior, same side exterior angles, right? We were proving the converses. We could not use anything that requires the lines to be parallel, because that's what we're trying to prove. We do not know at any point that the lines are parallel until we get to the end. So we were trying to always connect a pair of corresponding angles here and here. And when we connect a pair of corresponding angles and show that they are congruent, that is what's locking our lines into a parallel position. That is the converse of the corresponding angles postulate. If we have a pair of corresponding angles that are congruent, then the lines being cut by a transversal, they must be parallel. All right, have a good rest of your day.